What's up, my mathletes? That's right, Mr. Muscarella coming at you, and in this video we are going to take a look at evaluating polynomials. And there's going to be two techniques that we use to evaluate polynomials. One of them is going to be called direct substitution, and the other one is going to be called synthetic. So let's go ahead and take a look at some examples. Let's go. So with direct substitution, it's just what it sounds like. You're just going to take a number, whatever number they give you, and you're just going to simply plug that in anywhere that there is an x. Now, in this particular case, we're being asked to find f of 2. So that means anywhere there's an x, we're just going to plug in a 2. So when we write this, okay, because our notation matters. So we're going to write f of 2 equals, because 2 is the number that we're going to plug in. And then anywhere there's an x, we're going to plug in a 2. So we'll go ahead and we'll do that. And this is where you just have to be really careful to make sure that you put 2's in all the right places and then do your evaluating accordingly. Now this first one, when we go ahead and figure out 2 to the 4th power, so that's 2, 4, 8, 16, be really careful because don't forget there's a negative sign right out in front of that. So that is going to be negative 16. 2 to the 3rd power is 8, so we're going to have 2 times 8, and then 3 times 2 of course is 6, and then minus 8. Now we can clean this up all sorts of different ways. Now negative 16, and then we've got another minus 16, and then a plus 6, 8, and a minus 8. That's going to give us a sum of negative 2. So we just took these two terms right there, 6 and 8, or 6 and minus 8, and combined those and came up with that minus 2. So when we combine all of that all together, we end up with a grand total of negative 36. So the value of 2, if I were to put 2 into that polynomial function as my x-coordinate, my input value is 2, my output value would be negative 36. So whatever that function looks like, if I were to graph that, I would see that the y value is negative 36. So let's go ahead and use Desmos to check that to see if it does actually, in fact, do that. So after I put that function into Desmos, and then I can change it to a table of values, because you'll see right there, we've got a table of values for that, and you get that once you plug in the equation or the function. You just go to that, edit the list, and you'll see some of these other ones down here. You can convert it to a table, and that's what we did up here for this value, for this function. Now if I look over here, I got 2 and then negative 34. Now I'll see that over here on the picture as well. You'll see the 5 dots for whatever points I put in on my x values. The corresponding y values will be listed there for each one of those points. So here I've got 2, negative 34. So if I go back and look at what I did, wait, what is that? That's a righto, a typo, a mistake, whatever. But that's how we can check ourselves before we wreck ourselves. So you always want to make sure that you use whatever technologies you have available to check yourself as you go through that. Because mistakes are common. They're okay, but just take your time and make sure that you double check your work. Always. All right, that's it for this one. Just using polynomial, evaluating them using direct substitution. And we'll come back and we'll look at another technique in a moment called evaluating polynomials using that synthetic substitution. So a little bit different technique, and we'll talk about that momentarily. Until then, make it a great day, and I'll see you soon. Peace out.